Hello students, today we are doing questions from magnetic field. Actually, I haven't done magnetic field questions. When I was going through the playlist, actually I noticed there are no magnetic field questions, but there's one theory part. Actually, I have given you a set of equations, magnetic field equations. So if you do not know magnetic field equation, yes, go through the magnetic field equation video and you will learn the equations that are required here, right? So let's get into this question. Question is appearing very soon, right? Read the question, right? So in this question, actually they are asking us to find the magnetic field intensity at the center O here, right? And the theta value is given as 60, right? So basically we need one equation. It's the equation here, B equals mu naught I over 2R, where R is the radius. So applying this equation, this is actually for a complete cycle, a circle, remember that, right? Then here we do not have complete cycle. See now in this part, we have two different directions. Current goes in this way, current goes in this way, right? Then, so we need to check whether the magnetic field created by, let's say, this is part 1 and this is part 2. So magnetic field created by part 1 and part 2, whether can we add them or we need to subtract them, right? So how do you check it? We need to apply right hand grip rule, right? From the right hand grip rule, if we show we point the direction of current with the thumb, and the other fingers will show the direction of magnetic field, right? So here from the second part, I'm right. So in this way, if I point the thumb, actually the magnetic field goes in. From this direction it goes in, and from here it comes out. That means from the smaller part, the magnetic field will come out from the center, right? Then, of course, from the upper part, from number 1 part, let's put the grip, then it goes in, right? So we need to subtract these two, right? So let's apply the equation for part 1. Part 1, mu naught I over 2R is there. So we need to take the fractional value of the circle now, right? So 60. The complete cycle will be 360 and the remaining portion will be 300, right? So 5 over 6 portion is for the upper part. So that means 5, 6. So this is the part 1. Right. In the same manner, let's take the magnetic field intensity for the second part, right? Second part, mu naught I 2R, same thing. 60 over 60, 1 over 6, that is the fraction. So what we need to do is we need to subtract these two. Right. Let's subtract these two. Right? Mu naught I over 2R, that is common, of course. And this is a higher value. So 5 over 6 minus 1 over 6. It's 4 over 6. Mu naught I 2R. So again 2 over 3. Mu naught I over 2R. So I'm getting mu naught I over 3R as the answer. From the given answers, mu naught I over 3R, that's the third answer, right? It's not that difficult, but if you do not know the equation, you cannot do anything, right? So it's always better to remember the equation. Again, I'm telling you, go through the equation video. You will learn the equations and then you can get into the questions, right? Let's move into the other question. Now we are in the second question. So if you could do the first question, actually you can do this question as well. If you couldn't do the question, again the second question will be challenging, but go through with the explanation, then come to this question. Yes, you will be able to do the question for sure, right? So let's get into the question. In this question, they are asking us to find the magnetic field intensity at this point C, right? Here, in this point C. Now again in the very same method, actually we did the previous question. We need to find the direction of magnetic field, right? From let's write the letters they have given us. This is R, S, here Q, P, right? Then from SRS part, actually, yes, this part actually will create a magnetic field, not on C, because current goes in this direction, so it can create a magnetic field in perpendicular direction only, not in this direction. So even from QP, it's not possible. So no RS, no Q. Then yes, we have the upper larger arc and this part as well. It's then semicircle for sure. So let's write the equation for the larger one. So radius is R1, mu naught I over 2R2, but it's semicircle into half. Again for the smaller one, let's write the equation mu naught I same 2R1 half. Right. So now we need to check whether we need to subtract them or add them. Right. Again, right hand grip. The smaller one, current goes in this direction, so that means yes, magnetic field goes in from here and comes out from this direction. So it's coming out, right? So it's coming out from, for the small part, the dot. For the larger part, yes, this direction, it goes in. So we need to subtract the equation. So let's write the answer now, right? Mu naught I, of course, and 2 is common, right? And 4 actually. 4 is common. 2 into 2, 4. So we get 1 over, which one is larger? Which one? R2 minus 1 over R1. Yes, that is the answer again. We need to see which one is higher. So mu naught I divided by 4R2. R2 actually R2 is larger, so the value is smaller. So then it should be the other way around, right? Then mu naught I, the final answer, 4 over 1 over R1 minus 1 over R2. So in the given set of answers, it's the, yes, it's this 1, 2, 3, third answer. Right. We have the answers. So if you are not familiar with these type of questions, that means you don't know small theories, right? Again, I'm telling you, go through with the small theories, you'll be fine.